So here's an interesting example involving the method for finding a 2 by 2 determinant. So say if I want you to solve for x if the determinant of x squared, x is the first column, and 2, 1 as the second column is equal to 8. So now the first thing we should do is to evaluate this determinant. So just write that a little better. Now recall, if you have a determinant a, b, c, d, the way you figure it out is first you take cross multiplication of a and d, and then you take the cross multiplication of b and c, and you tie them together with a negative sign. So now, taking that, this determinant up here is going to become x squared times 1, and then the second one's going to be 2 times x, and we want to tie them in together with a negative sign, and that's all equal to 8. So now we have the makings of an equation, right? So we have simplifying, we have x squared minus 2x is equal to 8, and since we want to solve for x, we want to move the 8 over to the left side so that this ends up looking like a quadratic equation. So x squared minus 2x minus 8 is equal to 0. And whenever you see a quadratic equation of this form, your first instinct should always be to try to factor it. So we want to look for two numbers, which when you multiply them give you negative 8, and when you add them give you negative 2. After a little bit of thought, you see that x equals x minus 4, x plus 2 does the trick. So we have x plus 4, x minus 4, x plus 2 is equal to 0. And using the zero factor property, we know that x minus 4 is equal to 0, or x plus 2 is equal to 0. And solving each equation separately, we know that x is equal to 4, or x is equal to minus 2. And those are the solutions for x.